One of the biggest panics that people have about geometry on the SAT is over the unit circle, which, if you've gotten to that in school, was many days, maybe even many weeks of learning crazy things, crazy number combinations, memorizing stuff, doing quizzes about the unit circle, memorizing radians and degrees and fractions and radicals. It's a giant mess. Now, you don't really need that for the SAT. And there's a couple reasons for that. First of all, this question really doesn't have anything to do with it at all, but I'll even talk about it at the end, why this is even anything that seems like it's about the unit circle really isn't. Now, technically, this is a unit circle, right? Because what does that mean? In the xy plane, points P, Q, R, and T lie in the circle with center O. The degree measures of angles POQ and ROT are each 30, so let's do that. So POQ, that's 30 degrees right here, and ROT is 30 here. What is the radian measure of QOR? So that's going to be this guy here, QOR. Now, it's the unit circle because it is a circle with a radius of 1 unit, 1 being the value of P and T, -1 there, so it's a radius of 1. So the thought is that people are going to panic because if you have learned the unit circle, you're going to be like, oh my God, I don't remember it. This is what this is. It just kind of conjures those memories. This is really just an angle rules question, right? The top of the circle right here above is 180 degrees because it's a line. And so there's 180 degrees in a circle or in a line. And we have 30 accounted for on either side of angle QOR. So that's -60. That leaves us with 120. Now, again, the unit circle could come in and you'd be like, okay, 120 degrees, I'm supposed to memorize how many radians that is. Or you can just use the constants that they give us here, right? They say the number of degrees of arc in a circle is 360 and the number of radians of arc is 2 pi. That's just a ratio, right? So just set it up, right? So 360 degrees divided by 2 pi. That's our relationship. So that's going to hold no matter what angle we have. So if we have a 120 degree angle, we're finding that missing radian piece. So yes, there are other formulas. There are other things that you can do to memorize some basic radian measurements in degrees. Or this takes like 2 seconds and you don't have to memorize anything other than the fact that the reference sheet gives you then the initial setup. Degrees over radians, 360 over 2 pi. So just cross multiply, right? So 360x is equal to 240 pi. Divide by 360, divide by 360. This might be where you want to go to your calculator because 240 over 360, you can simplify that yourself, or you can just kind of let the calculator do it. I don't want to type the pi though. I just want to get the fraction part because the pi you can see is in all the answer choices anyway. So just leave that there. So 250 over 360, it's going to give you a decimal, but you can always hit this button and turn it into a fraction. So that is 2/3 pi. And is that an answer? 2/3 pi, choice C. Done. That's it. That's the whole thing. So notice no unit circle, anything. No like, oh, I've got to know that this number is this many radians and this point is this. It doesn't matter. But just to show you the things that you remember for the unit circle, the things you're forced to memorize are things like this 30 degrees, right? And if we broke it down even further, we would actually, there's probably another one that's halfway. That's the, I don't know how to draw this. That's like the 45 degree one. And then there's another line or another point over here you have to memorize. That's the 60 degree one, right? 30 degrees, 45 degrees, 60 degrees. Those are the things you're memorizing if you memorize the unit circle and you're memorizing the points that go with those. Why don't you need to memorize that for the SAT? Because 30 degrees, 45 degrees, 60 degrees are in the reference chart. 30 degrees, 45 degrees, 60 degrees. There's a reason these are special right triangles. And even if you don't fully remember the unit circle, you probably vaguely remember that all the other stuff you had to memorize for the unit circle involved radical 3s and radical 2s. That is not a coincidence either. It's because basically all that stuff you had to memorize was just kind of a shortcut for the special right triangles, these triangles that we can work with without having all the dimensions. And basically what the unit circle is doing is it's setting the hypotenuse equal to 1 for everything, right? Because that's the radius. That's if I were to draw a triangle here, right? it would look like this. It would be this right here is a 30-60 triangle, right? So the radius is 1, and then so this means this is 1/2, and this is √3/2 because 1/2 √3 is that. So if that doesn't make sense, don't worry about it. This is also a very difficult topic for people. So basically I'm using this and solving for everything. So 1/2 √3 maybe is another way to write it. This is not really going to come up in the SAT. But I do think I get a million questions about this anytime anything is remotely adjacent to the unit circle, because it is such a traumatic experience for high schoolers to memorize all this stuff and be quizzed on it a million times. And I think you see something that kind of looks like that, kind of reminds you of it, and it just like sets you off. But again, it doesn't really matter. That's not what they're asking about. So try to remember that if it's just about converting degrees and radians, that conversion is given to you. If it is more complicated and you need to understand things that are a little bit more similar to the unit circle, you don't have to have that memorized. You can probably use these special right triangles and get there in some other way. And regardless, this is not a topic that is going to come up very often. Maybe 1 in every 20 SATs is going to have something that remotely resembles the unit circle. So I hope that puts your mind at ease if it is something that panics you.